All right, let's go ahead and kick this off. Thanks everybody for joining us for session 2. Appreciate you taking the time out of your day for our second session in our 3-part series here on ASR. In this second session, we're going to focus on Azure Site Recovery's functionality and additional configuration. We're going to deep dive into application sandboxing, virtual machine failovers, and why these items can be so powerful and beneficial to yourself and your organization. A little bit of housekeeping items here at first. Who we are, we're Model Technology Solutions. We were founded in 2014 by IT engineers. We are delivery focused, not sales focused. We have a project delivery team to handle things like IaaS transitions, O365 migrations, Azure Site Recovery implementations, data center automation, Windows automated patching, operating system deployment, SCCM projects, and the list kind of goes on. We have a managed services team that we would consider an extension of your internal IT team to help with products such as System Center, Configuration Manager, operating system deployment, endpoint and server patching, application deployments, to name a few. We are cloud embracing. We want to help you determine what workloads fit for a transition out of your environment into the cloud, how to transition them as painlessly as possible, and how to manage those items post-migration to the cloud. Our mission statement: to empower our partners through services, automation, and optimization to become infrastructure heroes. Myself, for those of you who were here last week, I'm still Nick Taylor. I'm still a nerd. I'm still a senior consultant here at Model Technology Solutions, a little bit over 3 years. I'm still happy to be sitting in a mission control picture right there in Gene Kranz's chair, like a boss. Things that I enjoy, nerd things mostly, the cloud, virtualization, automation. I think the cloud really I enjoyed as much because it reminds me of the early days of virtualization. Just that paradigm shift in how we manage data centers and their services and provide them to our end users. Just a very exciting time to be part of IT, just like those early days of virtualization were. And automation. We've got so many new tools out there to help manage and deploy these things these days. Just really a fun time to be in IT. I've been doing it myself for the better part of 2 decades, and hopefully I'll be doing it for the better part of 2 more decades. I really do enjoy this field. So a little overview into our previous session and our future sessions. Part 1 was an introduction to Azure Site Recovery, some of its high-level terminology and topology, some configuration like moving virtual machines into vaults, high-level overview of that solution. Part 2, we're going to dive a little bit deeper into some more of its functionality and configuration, some short review from session 1, since we'll need some of those terms in session 2, and then we'll jump into the actual virtual machine failovers themselves and some application sandboxing we get while using Azure Site Recovery, which is just a great benefit of the tool. And then part 3, we're going to be looking at some more advanced scripting and logging, and bringing in other infrastructure items to possibly bring our data into Azure IaaS. So part 2 agenda. Our agenda today is recap some high-level items, look at our VM failover options, take a look at recovery plans, see how we could add some simple scripts to those recovery plans to add that automation for bringing these virtual machines up repeatedly inside of Azure IaaS. And we'll take a look at some recovery plans that I've already run for today's demo and create a recovery plan together in our demo. We'll also take a look at application sandboxing and how failovers and recovery plans, how we can use them to sandbox applications and do testing along with testing our disaster recovery process each and every time we spin those sandboxes up for upgrade testing. And we'll look at our VM failover options. We'll look at how we can fail over VMs, what our options around planning, what our options around failing those VMs are, and what each of our use cases are for those. We'll configure that recovery plan and we'll add those simple scripts. So let's take a quick dive into those items that we discussed in session 1 that we'll be rediscussing here in session 2 or broaching further. So what was ASR? It's disaster recovery as a service. We're letting Microsoft handle the time-consuming and operational details of running your DR data center. We're going to let Microsoft handle host patching, network patching, security appliance patching, any other appliance patching, storage patching, and keeping that DR site scaled to your production levels. Really, all of that care and feeding that we have to traditionally put into a disaster recovery site that takes time. We could also use Azure Site Recovery as a lift and shift tool, not only just for DR moving into a Microsoft data center in the event that our data center is down, but to slowly move workloads into the cloud. We're going to be able to use it to do testing, migration, and failback if those migrations don't go as planned, or we just need to move items out of our data center to perform maintenance, or possibly give us a little bit more capacity on those applications in the cloud or back on-prem. We're going to take a look at recovery vaults and that application sandboxing. So recovery vaults. They're our configuration and our tie-in to our logical sites, data centers, host clusters, or hosts, and how we get all these items together in a recovery vault. We also configure our replication intervals here for how quickly we block level replicate our virtual machines from on-premise into Azure, how quickly we take application consistent snapshots, and how these options and how to set options for where these virtual machines will fail over into, what virtual networks, what resource groups, how they act on a failover. And it's our one pane of glass for replicated and backed up data. It gives us a quick health check, stats, replication health, and a topology overview. And it's where we can initiate failovers on VMs on a VM basis or on our recovery plans themselves. And the recovery plans, we're going to have a good deal of focus on this today. We're able to set what VMs come up in what order. So this lets us break up our start groups into tiers. So we're going to create groups for starting Active Directory. Once Active Directory is up and running, we can start our database servers, middle tier servers, finally our web tier servers. And maybe we need to bolt in a load balancer and apply some network security groups, which we're also going to focus on talking today on. We could also add custom scripts to and all of around this. So if we want to, say, add a public IP to a jump box to let users into this environment each and every time, we could script that out. So there's no manual actions we have to take when we're spinning up these application sandboxes or running these recovery plans for our DR purposes. Really one-click failover to get these applications ready for testing. And while they're ready for testing, we just tested our DR functionality as well. We'll be running through a recovery plan that I've created and failed over prior to this demo, and we'll also walk through the creation of a recovery plan. So now that we had that refresher on the first few terms, let's look at our failover options once we have VMs successfully added to our vault. We have 3 failover options, and let's discuss them a bit deeper and what they provide for them in their use cases. So first, we have a planned failover. In this case, our primary data center is up and accessible, and we have some form of connectivity to Azure with either ExpressRoute or a site-to-site VPN setup so we can communicate with appliances and servers inside of our Azure IaaS environment. When we initiate a planned failover, the host agents on-premise shut down the related on-premise virtual machines. It's then going to start them up in our Azure IaaS tenant per the settings we applied to each VM when putting them into our vault. Items like storage accounts, virtual networks, resource groups, and we'll take a look at all these properties in the demo for the replicated VMs. When we initiate a planned failover, the host agents will shut down the related on-premise VMs and start them up in Azure. So if we have communication back to our data center, as it boots in Azure, we see the VM come back online. It continues our role in our environment after its blackout window. Just as an FYI, that blackout window can run anywhere from 5 to 20 minutes. So this isn't a live migration when you kick over a planned failover. It's going to be a small outage event, and it needs to be planned as an outage event accordingly. unless of course you have this VM participating in some type of a high availability environment, and if so, good for you. Move them one at a time, make sure to update your load balancers, and slowly roll those planned migrations up into Azure. So why would we do this? Probably because we've done some preliminary testing with test failovers, and we want to run this virtual machine live in Azure on that fabric with an easy failback option. Or maybe it's our busy time of year. We don't have capacity in our on-premise data center. We're running low on I/O on a SAN, we're running low on memory, compute, something that makes us need to burst up and move outside of our data center so we don't have to add capacity there. So we could lift and shift it up to Azure, burst it up for a while, and then bring it back on premise. Or maybe we're having issues at our primary data center. Maybe we need to perform maintenance on a host. We don't have an N+1 configuration anymore because we've grown. We have a secondary SAN we tie into and it needs more shelves added to it. Any of these options where we need to perform some maintenance and we don't have another host or cluster to migrate over to, we can perform a planned failover and shift that workload to Azure for either a short runtime, an extended runtime, or the rest of its life. We also have a failover. This would be unplanned. In this scenario, your data center is down. It's suffered some form of catastrophic failure. In this case, we're going to bring the virtual machines up in Azure. They're going to fail over to those specified values, attach to those virtual networks, and start running. As we click this failover, and I'll show it to you in demo, we have the option to skip, choosing to attempt to shut down a virtual machine on premise to save some time. If your data center is offline, it will just skip this step and begin booting these virtual machines as it expects them offline. And this scenario right here, an actual failover in a disaster, is the reason why this next step and option is so important. Test failovers. In my opinion, test failovers is the coolest feature of ASR right here. Not only does it give us the ability to test disaster recovery with zero impact on production, it could possibly eliminate other test environments along with that secondary DR data center that you manage that takes time out of your day. While using this as DR testing, the application sandboxing can give us a platform to get step-by-step options for upgrades on applications and services, either for our own peace of mind, or we can take these step-by-step processes that we ran against our virtual machines, our data in our environment, document them, bring them to a change management board for approval, so it's an easier process for it to get approval for those changes against our live environment. And it gets us an up-to-date sandbox for any replicated application every time we do this process. It also tests DR while we do this. So if we do a test failover and we bring SQL servers up in Azure Site Recovery, the rest of our applications, we have no need to refresh databases, refresh another disparate environment. It's truly our servers being brought into the Azure Fabric with up-to-date data from minutes ago that we can perform live operations against to test. And when we do this on a regular basis, if we ever do need to do that unplanned failover, if we're ever in a disaster, it makes that situation far less stressful. Your DR toolkit is like any other toolkit. The more we use that toolkit, the more comfortable we become with it. You understand the processes behind it. I mean, when was the last time you tested DR in your environment? How often have you followed that process? Do you feel comfortable with that process? I had to answer no to those questions in other environments I've worked at as a past, and ASR has been a great tool so you can start answering yes to those and get this host of additional benefits of application sandboxing and testing and saving yourself time from that care and feeding of other environments. So let's take a deeper dive into application sandboxing inside of Azure Site Recovery. One of the most important things of anything, including a DR plan, is repetition and knowledge of the items inside of there. Repetition gets us familiar with the process and makes it far less stressful when we do have to use it for that catastrophic failover. We want to use test failovers as much as possible. We want to use them for application upgrade testing, line of business app testing, configuration changes of those line of business apps. As an IT team, we could use them for more infrastructure-centric upgrades, like possibly performing a larger service pack upgrade on a SQL server that hosts a line of business app, or maybe even a SQL in-place upgrade that we wanted to test out. Upgrading your Active Directory schema, I mean, the list goes on. And every time we do this to test our process for an upgrade that's going to happen against our live environment, we test disaster recovery over and over. You can honestly tell auditors when was the last time you tested disaster recovery? Last week when we tested our line of business app. And we could use these items and these processes that we take and use in our test environments in this sandbox and use them for CAV approval scripts. We're going to know the results of every script we write, the steps that it takes to get from point A to point B in our upgrade process, the results against our VMs in our environment. All of this while having more time to prep for items such as this that are important to the business because we're offloading that work of maintaining that second data center and hopefully a couple other test environments to Microsoft. Then if disaster strikes, you have this deep and intimate knowledge of these recovery plans that you've created, the steps involved, how your items work and shift fabrics between data centers that you've automated and just can watch success and failures coming off of these scripts. It's going to be a stressful day in the event of an outage, but if you know this process and you've worked it recently, it's going to be much less so, and you're going to have a much greater confidence going into a full site outage. So why do we use test failovers? We want to use test failovers to test our applications and our servers on Azure fabrics. As we're moving into IaaS, there's a ton of differences in new terminologies to learn. I mean, test failovers ensure that we've configured base items per your environment's unique requirements and that everything is performing as expected in that new fabric. I mean, some of these concepts are new and intimidating at first, but with test failovers, all of these concepts that may have been misunderstood are caught prior to affecting anything in our live environment. Our first steps when using test failovers, as we're architecting these processes, is to let ourselves, engineers in there. We're going to validate the health of these servers and services. We're going to see how they perform from metrics from Perfmon and other tools that we've used throughout our journey, moving servers and services. And once this is done, we can provide access to users to test its functionality and responsiveness. So not only do we see the servers responding well and we don't see disk queuing, we get a user in there, put them in front of their line of business app, and have them replicate their month-end billing process in Azure. Get them involved in that process. Let them feel the differences between on-prem and cloud. So we need to think about security prior to letting those users in and prior to letting administrators in. Azure IP addresses are constantly being port scanned and are primed for attack. So we want to limit access to these virtual machines that we stand up in these isolated networks that we're poking small holes through to give access. We want to use network security groups inside of Azure. Network security groups don't incur any additional charges, so we want to use them as often as we can. The last thing we want to do while practicing a DR event or providing a new sandbox environment for application testing is to expose ourselves to a security breach. We want to make sure these isolated networks do not route back to our production networks. We want to make sure that we have them isolated. That's truly an isolated network. If we stand up versions of Active Directory in 2 linked environments, we're probably going to have a bad day. Just repeating this one more time, make sure isolated really means isolated. And I'll show you some of these steps inside of the VNets inside of our demo. So let's get everybody in there. Once we've got security covered, once we've done some base testing and we know that as engineers, we're seeing servers perform as we expect, let's let those users in. Let's let them do user acceptance testing inside of the cloud. In my experience, if we let users have a voice, they're less reluctant to change. I mean, we want to know if that application is performing poor in the cloud. Maybe we need to upgrade to SSD over premium disk. Maybe we need to upsize the virtual machine in Azure. Get them involved. Let them see their own processes. Let them see if it's taking longer. We're going to use old and new tools to get inside of these environments. For access to isolated networks, we've got tried and true remote desktop, but we've also got newer options, such as Azure Bastion. We can deploy this and not poke holes in network security groups. We can get that access just through the Azure console over a web interface if we deploy that infrastructure. So keep options like this in mind as you're planning out access into these isolated environments. And I'm a broken record on this one, but use network security groups. At the very minimum, lock down your RDP connections to known IP addresses from your data center. And I'm just about to show you an example of why in this demo. So let's take a look at a demo. Jump out of PowerPoint and jump right on into an Azure environment. Get there real quick here. Just as an FYI, I did start a couple recovery plans prior to the demo. Like I said, the blackout window is usually around 5 to 20 minutes, so I didn't want to run a short actually in our live environment, but I'll walk you through all this. So since we've been harping on network security groups, let's go there first. Move my window over here. And jump on into network security groups and virtual networks. So I've gone ahead and created this very horrible network security group rule called do not do this in production. And you could see my inbound rules. I'm allowing RDP, and Microsoft's nice enough to give me a nice bang on this to tell me it's probably not a good idea that I do this. My source is any IP address. My sort port range is any. I could go anywhere inside of my network as long as I'm going on 3389. And I'm letting this as my first rule. So if anybody in the entire world wants to try to hit 3389 on my server that I've got spinning in this virtual network right now, they certainly can. I would never do this in production, and I've just got a bogus virtual machine running in the related VNet to this network security group. And let's take a quick look at that virtual machine. I've had this machine up and running for roughly 24 hours. No other configuration other than giving it an admin password and setting it out there and putting one rule out there with a public IP and allowing RDP. It's the only protocol I have open right now. But if I do a refresh on my security log, you could see as of recently, which I'm off on my time zone on the server, I'm still getting attacked. So right now, folks are trying to log in to my box that I have running here because I set up a very poor network security group. And Shane's trying to log on my machine. I don't even know Shane, to be very honest. So I know that's not me. So over and over with now 16,000 some new events. Oh, here's failures. So I have about 1,000 failed logons against this environment right now, running just 24 hours, and they're not going to stop. They're going to keep pounding away and bashing at my RDP connections. So again, just remember, get some security there. Let me jump over to network security groups again and show you just a quick and dirty way to at least only allow access to machines you want to access your virtual machines in Sandbox. So here is an isolation subnet NSG that I'm using on our other virtual network. And I've limited RDP connections to at least my egressing IP from my data center. So that's the only place I'm going to be able to connect. No security warnings. And again, this is the very bare minimum. Add as many rules that make sense for your environment. Make sure it's not touching your live environment. And it's a totally isolated network. A way that I usually go about that is when I'm setting up the associated virtual network. Here's the do not use in production VNet. I have a completely separate CIDR address for this. So if my on-premise data center's address space is a class A and I'm using 10.100/16 network there, in my sandboxed isolated environment, I use a totally different CIDR scheme. Not only does this show me some visual differentiation between these two sites so I know where virtual machines are running, but it also lets me update DNS through automation scripts and know that I'm ready to move these servers and services into different CIDR fabrics. So there's my spiel there. We looked at how to properly allow one IP and different CIDR addressing. So now let's jump over to my recovery vault that I'm done harping about network security groups, but they're free. Use them. At least block RDP with them if you're not using Azure Bastion. Close this up, and let's jump into my overview for my recovery vault. So this is my recovery vault. So remember, this is my pane of glass to look at what's going on with virtual machines that I have replicating. It's my point of entry to do failovers on VMs and recovery plans. So right now you can see I've got 4 virtual machines replicating out of my lab. I'm actually performing test failovers on them right now, so this will refresh and show green as I collapse those test failovers, and we can kind of see a layout of our on-premise environment and how many storage accounts are involved in Azure Site Recovery. If I've got Azure virtual machines involved in this as well, or VMware, I could flip through those configurations as well, but I currently do not. So let's take a look at our replicated items. These are the virtual machines that I've got replicating via ASR into my vault. So as you can see, I've already got some test failovers pending on these. We'll look at our failover options on a demo SQL server that I've done nothing with yet today. So on this virtual machine, oops. So on this virtual machine, I forgot to hit reverse replication. I can replicate it back into Azure. And I have my test failover options and all the failover options available to me. So I can perform a planned failover on this virtual machine. Again, that's where I'm incurring downtime on-premise. My on-premise data center is up, and I'm looking to migrate this machine into Azure with a failback option. I have my actual failover option, which if my data center is down, I'm just going to click this, fail virtual machines over into Azure, and then I have my favorite feature, my test failover. So let's jump into a recovery plan and see that we've got these same options. So here's my recovery plan. I've got a test failover in progress over here. So if I look through here, I've already started performing a test failover. My options now are limited to clean up my test failover if I want to collapse the virtual machines that I've moved. Just so you could take a look at my on-premise infrastructure and my Azure infrastructure, here is my IaaS virtual machine spinning right here. You could see any virtual machines involved in a test failover are appended with a -test. And if I look at my on-premise hypervisor, you can see that they're still happily running. Jump there. And here they are. I've got a test failover SQL box and a demo Active Directory box running here and on-premise. Get that out of the way. Okay, and back into my recovery vault. I'm back in my recovery vault. So this is the one I ran, and we'll look at both of these virtual machines. And as I could see, I'm going to go to the actual test failover portion of this, and I'm going to walk you through the steps it took. So this is when I initiated that test failover. It brought up my demo Active Directory box and my test failover for SQL. I've got a script on here that's going to apply a network security group to the virtual networks involved every time I go through this process. Just in case someone accidentally removes it from a VNet, makes any changes, I want to make sure that's there. So 1, my users have access, and 2, I'm not opening anything up on the internet through a port rule. If you add in some error checking into your scripts, like a try-catch block, where you're seeing these successes over here, it will show a failure if it fails out of the script or for some reason can't apply that network security group. So then you can see Tier 1 starting, Active Directory. After Active Directory starts, Tier 2 starts to start my SQL server. And then I finally run another script to apply a public IP to that SQL server. Now this job is completely finished. I have these virtual machines spinning in Azure. So I have my sandbox up. So I'm going to flip over to my SQL server that I'm running inside of the sandbox. So let's just say I stood up this environment today because there's a DBA that wants me to run something against my on-premise environment. He's got a change that's going against a much larger upgrade or change plan, and he's got a handful of SQL scripts that I need to run. I'm not a DBA. It's just some gentleman handing me something that I'm going to run in my playbook for an upgrade tonight. So I spin up my test environment, I spin up my sandbox, I'm ready with SQL Server. As I did all this, I just tested my DR process for failover into Azure. I could see that SQL's up and responsive. So great, I'm going to run this gentleman's script. And I run the script. And that dropped all of my databases. Probably not the desired result this DBA wants. So I've actually ran this against my data. I didn't have to update data manually. All I had to do was click my test failover, test DR, and get myself in a sandbox scenario. I didn't have to update data, migrate databases, go through any other additional processes other than what I set up for disaster recovery. And I could jump back to on-prem, maybe if I can get past this little thing. Go away. There we go. Okay. And I can jump back to my on-prem hypervisor and see that I've still got my SQL Server box over here. And all of my databases are still there. Users are still happily using them. I haven't destroyed anything yet. Everything's going good. Oh, my databases are destroyed. We probably need to take another stab at this. What would be our next steps? Well, I want to collapse that environment down. So on my recovery plan, I would jump in here and I have the option to clean up. Clean up this failure, clean up this failover. It was a failure. And I could leave some notes in here. A script didn't work as expected. I won't throw the guy under the bus. It just didn't work. I want to tell it testing's complete. And over the course of the next 10 minutes or so, we're going to see all those virtual machines with that appended test disappear out of my IaaS tenant. They might already be showing that they're decommissioning. Not quite yet. So they're going to go from running to deallocating to finally removing themselves. And that'll be the cleanup of our test failover. And once that process happens over the next 10 minutes or so, we would be able to jump right back in our vault and start that test failover again. Get an updated script from our DBA, and maybe this time not drop a whole bunch of tables and databases. So now that you can kind of see some of the functionality of that recovery plan, let's just create one so you're familiar with the process. Jump on into recovery plans. And you can see status changes as we're changing status on these. It's cleaning up this guy. We'll go ahead and create a new recovery plan. And we'll name it Test 2 Tier Azure. We're going to select our source. It's going to be our hypervisor on-premise site. We're going to Microsoft Azure. And what's our deployment model? We want to use Resource Manager. Tyler's just using that. I'm going to start by adding in my demo Active Directory server, since that's going to be a portion of Tier 1. These are all machines that I've simply added to my Vault. I'm a Hyper-V environment, so I installed those agents on my hosts, and it's just reading the virtual machines I have access to bring up into the cloud. I'm going to click OK. Going to click OK. It's going to start creating this base recovery plan for me. And as that's created, we'll jump into it and we'll customize it. Let's customize this plan. Right now it's pretty basic. We've got one virtual machine and we're moving from our data center into Azure. Oh, we can see that we're going to do an all group failover, one machine, and we've got group 1 start. So these groups can be treated as tiers. That's how I usually treat them while I'm setting things up. And I've got Active Directory in there. Well, what do I want to do prior to booting any virtual machine? I want to make sure those network security groups are there. So before this happens and I start that VM, I'm going to add a pre-action to this step. And here's where we see that integration into our automation accounts. I'm going to give it some form of a logical name. And I'm going to select the automation account that that script lives in, and I get to pick it out of a list. And I can do all this via PowerShell as well if I want to. So I'm going to apply a network security group there. Hit OK. And now I can see before my virtual machine is going to start, I'm going to add that network security group to a VNet. Great. Now what do I want to do? Once Active Directory is stabilized, I'd like to bring up another tier. So I'm going to go ahead and add a group, which will be group 2. And inside of group 2, I want to add a virtual machine. So I'm going to add a protected item. I'm going to add my Test Failover SQL Server. I'm going to hit OK. And so now at this phase, we'd be applying an NSG. We'd be starting our Active Directory server. Once that comes up, we'd start our SQL server. It should come up, talk to the domain, start its services. Post that, I want to give users, admins, engineers some type of access into these virtual machines. So at this point, I could go into my IaaS tenant, click through networking, add a public IP address, set everything up, give public IP addresses to users, or I could just add another script that's going to do that automatically every time. So for this group, I'm going to add a post action for once SQL Server boots. Apply public IP, select my automation account, bind in my public IP script, hit OK, and save all of this. So in this flow, I'm going to apply that network security group so I'm secure. I'm going to boot up Active Directory, and it's going to be a prerequisite for my SQL Server environment. And then I'm bringing up that SQL Server to do testing. Once this plan is saved, I'd be able to initiate a test failover, see all those items complete, and get myself or other users in there to vet the change scripts, create that process, or do any testing that needs to be done against that environment. And you can see this successfully cleaned up my test failover. If we jump back into our virtual machines, we could see that 2 of those are gone, and we only have 1 existing virtual machine out here in a test failover scenario. So that cleaned up. Let's see one more thing here, and then we will jump into some Q&A. Replicated items. Cool. You could see that everything's in a protected state. Everything's failed back over. Let's look at this demo SQL Server. The last thing I wanted to show you was some of these actions. That plan failover, and test failover. What happens when you actually click the buttons, or what are the screens past it? So if I want to do a test failover, I click this button. I get to pick what recovery point I choose from, and then I get to pick that isolated network. So I've got an isolated network out here. If I click OK, this single virtual machine is going to begin failover in IaaS. If I were to click failover, same thing, it's going to ask me for a recovery point, except I don't get to pick network. The settings that I defined with this virtual machine, when I put it into the vault, that's what network it's going to drop into. So it probably should be a production network. I'm going to fail over. I want routing, everything user access already set up inside of that VNet. So when I move this guy, it's ready for action. It's a failover event. I'm moving it into Azure so users can access it. Here's that option. You can attempt to shut down virtual machines. If you don't, it's just going to use the latest recovery point. So if I click that, it's going to begin instant failover to Azure. And lastly, our planned failover. So where do I want to go? I don't really have many options here. From my local data center to Microsoft Azure, and I'm just going to click OK. So this is that option that's going to be used for migration and testing. If I click a planned failover, it's going to communicate with the host agents back on my on-premise host, shut that virtual machine down, and bring it up inside of Azure. Now, we might be able to catch that actually. Now there's this machine. It takes a couple minutes here, but that is going to shut it down, and I could jump back in here after some Q&As. I'm getting pretty short on time to jump into that. And as we go through all this, you could see status notifications, cleanup notifications, test failure notifications. So we could see where these are at, click on planned failover and see that prerequisite checks are in process. It's going to shut down my on-premise virtual machine, prepare that VM for failover, start failover, and then replicate that virtual machine back on-prem for that easy failback option. So that's a good deal of what I wanted to cover in the actual demo. Oh, here it is shutting down the virtual machine. Let's see if it does it. And then I'll jump into some QA. This guy. Oh, hey, there we go. So it shut it down already. So it shut down my on-prem VM. It's building it over in Azure IaaS. As soon as it's back up from that blackout window, I'm going to be able to access it since it failed right over into a known network and have routing configured from my data center. Yeah, there we go. So preparing for failover. And we might be able to see it building out over here. That'll be there in a minute. But anyway, that's a good quick dive into our failover options and recovery plans. Let's go and start the PowerPoint deck back up and jump into some questions and answers. Questions, feel free to type them in there. I'll try to answer any of them that you might have or take them offline and get you answers. But if you have anything, just feel free to dump it in the chat window now. I'll give you a couple minutes to type stuff if there are questions. Give it a minute or two for anybody to type things in here. And while people are typing things in here, I'll probably pop over and just look if I can see those VMs building out in Azure. Not yet. Planned failover, starting failover. No questions yet. I'll give everybody about another minute or two while I'm just clicking refresh on the screen. We might catch it, but it's Azure, so it might take a couple more minutes to build out a virtual machine. It totally will happen. There we go. Oh, we can see it's beginning to build here, so it's still got some temporary naming objects on there, ASR temp, but that's our virtual machine in the process of being created from doing that planned failover. Once it does live in Azure, we have the same options. We commit that failover over here and resynchronize back to our on-premise data center. If our migration doesn't go well, we can collapse it here in Azure, bring it back on-prem, finish our maintenance on our host VMs, anything we need to do there. All right, nobody has any questions yet, so I will continue on into the slide deck. If anybody thinks of anything, feel free to throw them in a chat window as we go. And I just want to say thank you. Seriously, thanks for taking an hour out of your day and spending some time with me and listening to my ramblings on ASR and network security groups and replication policies. For our next session, we're going to dive a little bit deeper into scripting, see what other type of custom scripts you can throw into Azure Automation to help you with this process as you're moving Fabric. Maybe you've got some DNS changes you need to make. Maybe you've got some functions you need to perform against your local virtual machines. Let's throw in some hybrid runbook workers into the mix so that we could actually perform PowerShell actions against our on-premise VMs. Maybe we have a storage appliance we'd like to use and bring some items up into Azure with us. Just some more advanced functionality and features. And that is it. Thank you so much for joining us. I hope to see you again next week. And I know this video will be posted on our blogs and on our website. So if you want to give it another look or have any follow-up questions, please just reach out to us. And again, thanks so much for spending part of your day with us.